Alright, I understand. Now that's all well and good, but we have never seen a quadratic function given to us in this form before. So how can I convert a regular quadratic function into something that looks like what we've just been talking about? Well, let's check that out, and we'll take it one step further afterwards, and we'll see how to sketch it. Let's go.
Alright, so it's now time to learn how to convert a normal function, that is y equals ax squared plus bx plus c, into turning point form, that is the one that you can see above here. Now, what the question says is convert the function y equals x squared plus 10x minus 3 into power form, which means turning point form, and hence state the coordinates of the turning point and whether or not it is a maximum or minimum value for y. Okay, and of course what that maximum or minimum value is. So let's go through and do that. The very first thing we need to do is we need to write out the equation. So we've got y is equal to x squared plus 10x minus 3. Now what I'm about to show you is actually going to look very familiar because it's just basically the first few steps of completing the square. So let's go through and do that. So the very first step is to go y is equal to x squared, and when we complete the square we go plus 10x. Then we're going to add half of that squared, so you go 10 over 2 squared, then subtract the same thing again, and then minus 3. Alright, the next step therefore is to go y is equal to x squared plus 10x plus 10 on 2 is obviously 5 squared minus 5 squared minus 3. Now what we're going to do is we're going to circle all the numbers that we need to do in order to put down into the completing the square method. So you go x plus 5 squared. So we're going to take that down now, and we're going to get y is equal to x plus 5 squared minus 5 squared is 25 minus 3. We therefore can go y is equal to x plus 5 squared minus 25 minus 3 is negative 28. So the question says convert the function into the turning point form. Well, what you can see here is something that looks a lot like our form y is equal to a bracket x minus b squared plus c. Okay, because obviously we've got our bracket squared that you can see here, we've got our c value, and our a of course is 1 out the front. So what we can do is we can go through and label each one. So our a is 1, our b is here, being negative 5, and our c is negative 28 that you can see here. So the question then says find the coordinates of the turning point. Right, so let's go through and do that. We write turning point is at the coordinates negative 5, because it's the opposite to b, negative 5, negative 28. Excellent. So the question then states find the maximum or minimum values for y. So what you can see here is it's going to be a minimum value because what we have is a positive 1. So because it's a minimum value, it's going to look like that. And it's going to be a minimum value of negative 28 because that's the coordinate of the turning point there. And there you go, that's it. That's how you convert regular quadratic functions into turning point form, so you can then find the coordinates of the turning point. Rightio, so it's now time to press pause once again and attempt the following question, that is, convert the function y equals x squared minus 7x minus 3 into power form, and hence state the coordinates of the turning point and any other transformations that may have occurred. And part 2, sketch the function and state whether it's a maximum or a minimum. Alright, good to see you back. Now because it's such a big question, what I'm going to need to do is just scroll down here and give myself some more room. Alright, and now here you can see my solutions. Right, so the very first thing I've done here is gone through and written out the equation once again, and of course when completing the square what I need to do is I need to look at the b value, so that's negative 7, and I divide it by 2, square it, and then halve and subtract it, as you can see in this section here. The next step is to circle the x, the minus, and the 7 on 2 with the squared, take that down to here, as you can see, getting us x minus 7 on 2 squared minus 7 on 2 squared minus 3. Now 7 squared on 2 squared is 49 on 4 minus 3. And of course when I convert 3 into a common denominator of 4, what I need to get is negative 12 on 4. And 49 on 4 minus 12 on 4 is negative 61 on 4. Now as you can see here I put it into the form y equals a bracket x minus b bracket squared plus c, where my a value is 1, my b value is 7 on 2, and my c value is 61 on 4. Now to find the turning point I use my b value, so that's 7 on 2 down here, and my c value of 61 on 4, but of course it's a negative out the front, so it's negative 61 on 4. Now this is a little bit harder to sketch until I go through and convert it into a mixed number, because that will make it a little bit easier to plot. So 7 on 2 is the same as saying 3 and 1/2, and negative 61 on 4 is negative 61 divided by 4 is negative 15 and 1/4. Next part of the question says talk about any transformations that have occurred. So we look at our a value first of all, and we can see because it's just 1 there's been no dilation factor and there's no reflection, so therefore we just don't talk about it at all. Our b value, well, we can see that's been translated 3.5 units to the right because it's a negative, so it goes to the right. and our C value says it's been translated 15 and 1/4 units down. The next part of the question says sketch the function and state whether it's a maximum or a minimum. Alright, so to sketch the function, what we need to do is find our x and our y intercepts. So to do that, I need to make my x equal to 0 in order to find my y intercept. So I've written out the equation that you can see here, then I've substituted x equals 0 in just below. So you get 0 squared minus 7 times 0 minus 3, then 0 squared is 0, minus 7 times 0 is 0, minus 3 is negative 3, so that gets us the coordinates 0, negative 3. Now let's go plot that in. So you get 0, negative 3, so that's negative 1, negative 2, negative 3, which is here, and we'll just write in 0, negative 3. We may as well plot our turning point that we could see before over here. So that was 3 and 1/2 and negative 15 1/4. So 3 and 1/2 is down here, and negative 15 and 1/4 will be around about here. To find our x-intercepts now, we make our y equal to 0 that you can see, and I'm going to use the equation that we found out once we complete the square, because that's just going to make our life a little bit easier. So to do that, what I need to do is make my y equal to 0. I then add 61 on 4. Square rooting that now gets us plus or minus the square root of 61 on 4 is equal to x minus 7 on 2. And then when I square root the 4, I get 2, so I get plus or minus the square root of 61 on 2. And now I can add 7 on 2 to both sides, getting a 7 on 2 plus or minus root 61 on 2 is equal to x. Putting them over the common denominator of 2, what you can see is I get 7 plus or minus root 61 on 2. And now I've broken up into the two terms, so you get 7 plus root 61 on 2, or 7 minus root 61 on 2. Now that as a coordinate is 7 plus root 61 on 2, comma 0, and 7 minus root 61 on 2, comma 0. Now this is kind of hard to sketch, so what you need to do is you need to just put that into your calculator and find an approximate value, so that gets us 7.40. So what we're going to go is 7.4 over here, but I'm going to of course write out the exact solution, so that is 7 plus root 61 on 2, comma 0. And over to negative 0.4 once I put this into the calculator, so this is over here roughly, and once again I'll write that out using exact values, so you get 7 minus root 61 on 2, comma 0. And now you can see I've got my dots, my 1, 2, 3, 4, my turning points, my x and y intercepts. All I need to do now is go through and sketch the graph. So to do that, I'm just going to join the dots, coming up through both of these, and I draw my arrow at that end. And I'm going to do the same going through the x-intercept up here. You can see there. Now the last part of the question says state whether it's a maximum or a minimum. Well, the turning point down here of 3 and 1/2, negative 15 and 1/4 is actually going to be a minimum. So therefore the function is a minimum.
I see. So we just need to do a little bit of completing the square in order to convert it into turning point form. Actually, wait a second. What happens if there's an a value at the front? Because it's really hard to complete the square then. Right, well, let's check out a worked example on how to do just that.
Alright, so this worked example says identify the coordinates of the turning point of the graph y equals 2x squared plus x minus 4 using algebraic methods. Now, in order to be able to identify the coordinates of the turning point, what we need to do is convert this function here into the power form, that is the turning point form. And as you can see, that is y equals a bracket x minus b squared plus c, whereas this is in y equals ax squared plus bx plus c form. Alright, so to do that, let's first of all go through and write out the equation once again. So you get y is equal to 2x squared plus x minus 4. Now, in order to be able to turn it into turning point form, what we need to do is go through and complete the square. Now, as we've learnt before, you cannot complete the square if you've got an a value out the front. So what we need to do is take the a value out as a common factor, even though it really doesn't have a common factor there. So to do that, what you're going to do is you're going to go y equals 2 bracket x squared plus 1/2 x minus 2. Because 2 times x squared is 2x squared, 2 times 1/2 x is x, and 2 times negative 2 is negative 4. Now what we can do, now that we don't have an a value at the front of the x squared anymore, is we can go through and complete the square. It's just going to be a little bit harder because we've got this fraction for a b value. So let's go through and do that now. So you're going to get y is equal to 2 bracket x squared plus 1/2 x, and what we're going to do is we're going to half and square the b terms, so that's going to be plus half of 1/2 is 1/4 squared minus 1/4 squared minus 2. Now, if you're not sure how to half a certain fraction or whatever, what you need to do is just go 1/2 divided by 2, which is equal to 1/2 divided by 2 on 1, which is equal to 1/2 times 1 on 2 when you flip it over, and that's going to get us 1/4. Just rub that out though now, so we got some room for later. And so now what I need to do is go through and circle all of the bits that will go into the brackets when I complete the square. So that is the x, the plus, the 1/4, and the squared. So that's going to get us y is equal to 2 bracket, a little bracket, x down from here, plus 1/4 squared. Then I write out the rest of it, minus 1/4 squared minus 2, close bracket. Alright, go through now and expand the 1/4 squared, so that gets us y is equal to 2, double bracket, x plus 1/4, square it, minus 1/4 squared is actually 1 on 16, minus 2, and let's put the 2 over a common denominator now of 16, so we're going to get y is equal to 2 bracket x plus 1/4 squared minus 1 over 16 minus 32 over 16, because 32 divided by 16 is 2. Take it up here now, we end up getting y is equal to 2 bracket, and another bracket here, x plus 1/4 squared, negative 1 over 16 minus 32 over 16 is negative 33 over 16. And now what I've got here is something that looks almost like the function y equals a bracket x minus b squared plus c, but it's not quite, because I've still got the 2 and the other brackets here. So what I need to do is expand it again, taking the 2 across over to each one of these terms here. So you got y is equal to 2 bracket x plus 1/4, because when I multiply the 2 times the bracket, you get 2 bracket x plus 1/4 squared, minus 2 times 32 is 66 over 16. I can go through and simplify that now, so I get y equals 2 bracket x plus 1/4 squared minus, you can see that 2 goes into both 66 and 16, so it's going to get us 33 on 8. Now the question actually asks for the turning point. Well, I can get the coordinates of the turning point from my b value and my c value. So the turning point will be at negative 1/4, because it's the opposite of the sign here, comma, negative 33 on 8 for my y value. And there you go, that's how you turn an equation into turning point form when you've got an a value out the front of the x squared.
Alright guys, thank you very much for tuning into today's lesson, which as you know is absolutely action-packed. We had plenty that we went through. We discussed how to work with quadratic functions in turning point form. We learned how to sketch these. We also learned how to discuss the different dilations, different translations, and reflections that happen when they're in this form. Now, like always, make sure you stay tuned for the very next lesson, because we're going to learn all about how to find the points of intersection between a quadratic function and a linear function. That is something that looks like this. That's right, we want to find whereabouts these two lines cross over. So of course, stay tuned for that lesson, and like always, say hi to your maths teacher for me. Morsey out.